Welcome back to the channel, everybody. There has been a lot of talk of leaking lapidary saws. This is something I have experience with. Here is my lapidary saw. This is a 14-inch saw right here, and it has a leak. I have all of the skills, knowledge, and tools at my disposal to repair a leaking saw, yet I have never repaired this leak. And I'm gonna explain to you why. A little bit of a background here. This saw has Mojave lapidary internals. Back in the 1960s and 1970s, Mojave Lapidary made kits, and you could order a kit, get that kit, and all of the sheet metal work, all of the saw body was something that you would source yourself, and you would do all of the welding and fabrication and put your internal components of like the rails and the carriage and the vise inside it, and that's how you could save a lot of money. I look at a saw from the 1960s and 1970s as being very different than a saw being sold in 2025. If you told me that you have a truck from 1968 and it has never been gone over and it has no leaks and it's been a driver, I would be very skeptical. Things over time develop leaks. Now, there is a series, in my opinion, you have a seep where it's like a little bead running down the outside of the saw. You have a leak that is more like a drip where it's like, and then you have like something where it doesn't really hold oil. That's kind of the spectrum that I look at a leak within, right? Like that's kind of how I rate it. This saw here has a seep. So about a tablespoon of oil every single month runs down the leg of the saw, and I have never fixed it. We're going to be discussing fixes, things that you can do, things to take into consideration. Often people will say, just weld it and be done with it. Well, I have over 10 years of welding experience. I have welded professionally. I have welded for money. I have developed products that I welded together and sold. I am by no means a professional welder. There's definitely people out there watching this video right now that are more experienced than me. My experience mostly lies in the world of MIG welding. However, I have done aluminum spool gun, a little bit of stick, but it gets complex when you're working with 3D objects such as a saw that is fully finished and fully constructed. Now, saws, as we know them today, have not changed a whole lot. The construction is basically the same. We'll be delving into this, and we will be talking about why these things need to be good to go leaving the factory today in 2025, some of the things that you might consider with an old saw such as this, and why welding your saw is not that simple, and also why epoxies, JB Weld is not a permanent solution. That is a Band-Aid. It is a Band-Aid solution. So saws are mostly the same in that you have plates of steel, okay? Welded together, and that makes a box. And on that box, you have all of your components, like your motor, like your pulleys. You have legs, okay? We have legs, and these legs are angle iron welded on, and that is essentially how almost all slab saws, lapidary slab saws, look. There's exceptions. I've seen some cool and interesting designs, but for the most part, this is kind of the basics of what we are talking about. Here you can see what I'm talking about. There is a little darker spot right here on this tray. This tray, by the way, is kind of my solution to the seep problem, and it is a replacement tray for a large dog kennel, and that catches this little seep right here. Now this leak is coming from inside here where the leg is attached to the saw body, so that you can kind of see the construction of this. I know that's very dark. Let's get a light in here. So you can kind of see how this is constructed. That's where the leak is coming from, up inside here. Now, the leg is covering a certain amount of sheet metal, right? So the leak is not necessarily right here where, it's easily accessible. It could be that the leak is on the inside of this. So that would mean to actually fully do a 100% lifetime repair on this, it is a giant operation to fix post the saw being, completed. For demonstration purposes, we're going to be looking at a piece of angle iron that I have clamped in the vise. This represents the leg of a saw. These two pieces of wood represent the two panels, the two panels of the saw body. One comes in like this, and you can see there's a little gap in there. This one comes in and it meets it. This is generally not welded on the inside, okay? It is going to be welded on the outside, filling that little void, and that perfectly matches the radius, it doesn't perfectly match, but it's close enough of the radius of the inside of a piece of angle iron. So now you can have this welded saw body, and it will fit in here nice and tight. You can now weld along the top of this, the bottom of this, here. But you have this void. You have this little gap here, okay? And that gap is where I believe this thing is leaking. So to weld the inside of this, which is being hidden by the leg, you have, a couple of options. Obviously, pulling the whole leg off, which is a huge, major operation for the repair of the saw, would be ideal. Welding up the inside of the saw, or welding all the way around, right, the perimeter of the saw body connected to the angle iron leg. That's really your only options, right? Because if the leak is on the inside, you gotta plug that up somehow. The way to prevent this from the get-go for a new saw would be before it's painted, before all of this stuff is inside it, before all these components are on, you leak test it. You put something in there with a dye, and you look on the exterior of the saw and look for a leak. That is the solution. Older saws, like I said, it is a problem. If you have a leak that is on an exposed right angle, much easier, but still problematic. You have to grind off all of this paint. You have to weld it up. You're going to heat this saw, and depending on where it's at, you will create warping. That's what happens when you dump a ton of heat into a metal object. This is really hard. This is really hard. We have welds on the inside here. That means having a die grinder. Really, the way to fix this, if I wanted to fix this right now, I'd pull all of these components off, every part of the saw, get it, hood off, get it down to just the tub. Then once it's down into the tub, I'd be using, everything you see here. Let me explain what all of this is for those that are new to this world of welding and repair. This here is my MIG welder. It's a Hobart. It's not the best unit. It's not like super high-end Lincoln or Miller. It does get the job done, especially for, working with your mild steels. I have done spool gun aluminum with this. It's pretty good. Back there is my gas bottle, welding hood, and then this thing. This is a kind of an important part of trying to make a repair like that, okay? I'm trying to stress to you the complexity of this, because if you just go over there, welding on the legs, the body, there will be like some twisting action happening. This here is a Certi-Flat welding fixturing table. It has all these holes that we use for securing things. So a new saw, when it's being built on something like this. And there's a series of jigs and fixtures and clamps that hold everything down in place really, really tight. A good example of that is this, okay? This is a 45, 90 degree angle. This is 1/4 inch steel, and I can bolt this down and create all of these flat stops where when I'm assembling something from scratch, it is bolted in. These are bolted in place. Different clamps and fixtures hold the saw, which is getting welded together, in place. So when you're welding and dumping all of that heat into the saw, everything stays in place for the most part. That's the best way. You are not going to dump enough heat into a saw that is old and already constructed without something like this holding it in place and not experience some level of twist or warp to the legs of the saw. It is just a major, major operation to gut this thing over here, get the body up here, cut the leg off, re-weld everything together. I mean, and when you're welding, you have options of like little spot welds, which probably not the best. Some of the welds that are on an inside right angle, think like this in here, an inside angle, you really have to have a big air compressor and like a die grinder and grind out the old weld to be able to get in there and penetrate when you're welding so that you have a good solid connection. The more you weld, the more heat, the more warp. That's why this saw is the way it is. And I'm not gonna fix it. It is just a huge time commitment, and I have all the stuff. If you don't have the welder, if you're using welding without gas like flux core, that's gonna be a problem. You have to remove all the paint. You're gonna burn the paint, right? It's almost inevitable. Or you're gonna be grinding away a huge portion of the paint and you're never gonna match it up. Less of a problem with this thing, more of a problem with a saw that has a brand new powder coat. You are effectively buying, you're literally in that scenario, buying a brand new thing. Like, you don't want your 2025 car to leak oil in your driveway. Your 1968 truck or car, you give it a little bit more of a pass, right? That's the difference between used cars and new cars. New cars eventually become used cars, but still, that's just kind of the gist of why this is such a problem. It's such a problem, and it's not an easy fix. It even gets more complex when you take relatively thick steel of a piece of angle iron, let's say 1/8, 3/16 thick steel legs, the angle iron, and you have a relatively thin piece of plate steel or sheet metal for your saw bodies, and welding two varying thicknesses of steel together does become more complex, especially if you're new. If you went to Harbor Freight and got a welder there and you're flux coring it, you could potentially create other issues like blowing through the thinner metal by having the welder turned up too much. It really is a nightmare. It's a nightmare scenario for most people if you don't have all the stuff, right? Big thing for me is I don't have a big enough air compressor right now to run an air-powered die grinder to really like hog out welds that are on inside joints. And then you have the issue of how you're going to weld it, the fixturing. Are you doing this on the ground like this in this orientation and welding up overhead? That's hard for people to chase your beads. Like, saws need to be coming from factories, not leaking. Not leaking. This guy, I give him a little bit of a pass. If this was a bigger problem, if it was a drip, or if it was like a pour, I would have done it a long time ago. Tablespoon every month, a little wet spot in my tray. Doesn't really hurt my feelings on a saw, of this age. I don't even have any of it here as an example, but this is JB Weld. I'm sure a number of you are familiar with it. If you're not, it is two different tubes, like an A and a B. You mix them together and it starts to chemically cure and get hard. And this is marketed as a solution for all kinds of different things. Leaks, is one that often comes up. A lot of people talk about that, which is understandable. However, it's like that guy from Flex Seal that slaps a piece of tape onto his leaking aquarium or whatever, and it stops it. Well, these are not the same as welding, okay? These are temporary solutions. If you have a hole in your radiator of your car and you JB weld it, yeah, it might get you home, but it's time to get a new radiator. Hole in your gas tank, JB weld might stop it, but it's eventually gonna leak again, time to replace it. That's kind of the concept here, which you can totally do. You know, I would ask you this. Let's say you have a saw that has 3 gallons of oil in it. If you dumped 3 gallons of oil on your floor right now, well, what would it be? How big of a deal would that be for you? You know, something to ask yourself. Usually, I've seen these things kind of fail, or heard of them failing in kind of a little bit of a spectacular way at times. You know, it's the way things go, right? Well, let's do some artwork here. Now, this is of course going to be a bigger blown up view so that we can demonstrate some things. Let's say you have a hole in anything, any kind of plate of steel. This is the hole, that's the hole. When you put JB weld on it, now imagine this is like ultra pin. This is a pinhole, maybe it's dripping, maybe it's a seep, whatever, doesn't really matter. When you put the JB weld on, it does not entirely fill this hole, right? It doesn't. It's like putting a piece of tape on something, a little bit better. Now, you can kind of smush it in. And this red here represents the JB weld that you put on. The blue is going to represent the oil. Now the oil is still fully filling this space, and you really only have this little tiny point of contact at the corner, at the very corner where you kind of shoved it in. You tried the best you could, but it's not a seal. It's not a seal. And over time, what's going to happen is that's going to go away, and that oil is now going to find its way over here and start coming down. Well, you don't have X-ray vision. You don't actually know where that problem occurred, okay? You don't know. So maybe you are going to, belt and suspenders it, and you are going to JB weld both sides. And you're like, well, cool, I'm gonna JB weld both sides of that little hole, okay? And, maybe you glop it on, it's like a big blob, essentially, on some metal. The bigger the blob of JB weld that you try to put on there, you don't know where the oil is coming in from and getting in here. You don't know. So now, not only do you have the problem of the leak, you don't know if it is even where it's coming from and how to fix it. You're trying to clean your whole saw. You don't want to put JB weld on something that's super oily. You want the best connection possible. That means removing the paint, fully degreasing it, and fully degreasing it, and then roughing up any of the surfaces, like 80 grit sandpaper, and get maximum adhesion on it. If I'm 100% sure on where the pinhole leak is, I'm going in with a much larger drill bit. I'm drilling out that hole, so now it is significantly larger, okay? It's significantly larger, and I'm probably coming in here then, and I'm using something like, I think there's like there's a product called like Fire Stick, and it's a more putty-like JB weld, essentially. And I'm going to make a little worm of that, and I'm going to come in here and pack this hole that I enlarged with that product, okay? And probably while it's still soft and it hasn't fully set up yet, I'm then coming in maybe with even JB weld and with JB weld and coming in here and really reinforcing it around both sides. And mind you, this is after grinding your paint off. I think that's going to give you your best bet at plugging a hole with JB weld, which some of you might want to do. Still nowhere near as good as the weld option. and nowhere near as good as original manufacturers just putting some liquid with some dye in their saws before sending it out the door and making sure it doesn't leak. I'm sure there's some welders out there just like that want to slap me around after this because like I said, I have experience. I'm not an expert in welding. Lots of things can be welded that don't require a whole lot of skill and effort. Farms across America are filled with field repairs. A guy with like an old Lincoln tombstone stick welder and just like buzzing stuff together, fixing gates, fixing things, and they hold up and they last. Where it gets complex is when you have a three-dimensional object that can twist and warp in different gauges of metal, and it needs to be liquid tight. So particular care needs to take place when assembling something like that. That is kind of my point here. I hope if you are going to do the JB Weld, I would suggest you drill out and kind of do that method that I was talking about. If anybody watching this has other advice on fixing a leaky saw, maybe I missed something, or maybe you just think I'm totally wrong, please drop that comment down below and let me know your thoughts. Maybe we can brainstorm, and maybe there's another solution out there that I'm unfamiliar with for fixing this type of problem that people have. So I hope you found this helpful. If you like this type of content, educational content about lapidary, rockhounding, all these things that we know and love, and you're able to support this project, you can do so by heading on over to Patreon. There'll be a link down below in the description box of this video. And thank you so much for making it to the end. I appreciate you, and I will catch you on the next video.